Okay, read the question. Okay, there is a block. And there's a bullet. Same, I think the initial diagram only. What is the condition? The bullet will pass through. It will pass through the block B, block A. So till now what happened, we took all the problems where it was just getting stuck, no? So let the bullet pass through the block A. What about the impulse? Will there be any impulse on the block A? Yesterday I discussed one pathfinder problem at the block lift, no? So one of the problem I discussed. So when the bullet is passing through the block A, will there be any force exerted by the block A on the bullet? Yes, it will be. And for what time the bullet will take? 1 hour, 1 day, 1 hour, 1 minute, 1 second, some micro milliseconds open, the bullet will pass through the block, no? And the force exerted by the block on the motion of the bullet, that force into time will be impulse. This is very important. The resistive force into time will be the impulse here. So what is the basic background? The background is like this. Huh? So when there's a block A, when the bullet is moving inside, here it is moving inside here. So let's take some velocity V1. So will there be any force acting on it? A resistive force, Fr you call it. And that resistive force Fr should act on the block. And for what duration of time the bullet will be inside the block A? For small duration of time. So definitely what this resistive force into time will be an impulse. Not normal contact, better called resistive force here. The idea is different here now. Let the bullet be C. That Fr into delta T will be the, and here a string is there, no? So look at that Fr into delta T will become an impulse. So shall I write delta T? So this Fr into delta T is the impulse due to the resistance. Now write down the equations, no? So the bullet will finally will emerge. So it is given for us. It will emerge with a speed. Where is that one? And comes out with a velocity 100 meter per second. So let me take velocity of the bullet, Vc. Tell me in what direction the impulse due to resistive force, Fr into delta T. So shall I show that impulse Jr like this? Then string will jerk. So impulse due to this. So in what direction you expect the blockade to move? In this direction. Then string is suddenly jerk an impulse. So here this will start moving. So we don't know JR, no? How to calculate JR? I'll take help of the bullet. So look at the bullet here, mass of the bullet, MCU minus JR equal to MC into VC. We know U and VC. Let me write all. Mass of the bullet is how much? 0.25. Initial velocity of the bullet 200 minus JR A very good problem. Impulse, it's not like something just writing some equation. Even the resistive forces also can set up impulse. That's what this numerical is. So I'll get the value of JR. JR will be 25 Newton seconds. Now I know JR. Can we write equation? Looking at the block A and B. Looking at block A and B. This one. So initially, what is the state of block A and B? They are at rest, no? So therefore, this should be JR minus JT equal to MAV. JT equal to MBV. I'll add up these two. So JR is equal to MA plus MBV. Adding up these two. I know JR value, I'll get V. After getting V, I'll calculate the impulse JT. So what is this? Impulse due to resistive force. So once again, impulse due to string, impulse due to normal contact, here impulse due to resistive force, what you have come across. What should be the value? 25 Newton. So this will be, let's substitute all. MA is how much? 1 kg, 1 plus 2 into V. So V equal to 25 by 3 meter per second. Now calculate JT. MB is 2 into 25 by 3. So these are the answers, like this impulse due to now next is asking impulse by the string. That's what JT know. Next afterwards, impulse by the particle on block A. That is what JR is asking. 25 Newton. Velocity of the 2 kg block just after the bullet comes out of that one. So the expression for V is asking velocity V 25 by 3. Then maximum displacement of 1 kg block in the left direction. How to get this? So this will undergo retardation, no? The block A and B, what is the next type of motion will be? The weight, the acceleration, the block A and B will undergo retardation. They'll describe a retarding motion. They'll have velocity. I'll show it here only. You can see that this will be V dash. How the weight will act? Downward, no? So what is the motion of both the blocks will undergo retardation. How to calculate that retardation? Mg by retardation is what? Mbg by Ma plus Mb. Then what is H is equal to? H is equal to V square by 2A. The block B, what is the motion of the block B? It will undergo retardation, comes to again it starts falling down. So it will ascend some maximum height. That maximum height is what we are calculating. From where these formulas are brought? Laws of motion. Because mbg is the weight acting downward opposite to velocity. So mbg minus t equal to mb into a, then t equal to ma. Solving that will get acceleration. And it's in fact it's a retardation. From where this equation is brought? 0 square minus v square equal to check calculation like this. Now take the next one.
So can you once scroll up?
Okay, ma, here.